Can I ask you a tricky question? So, if I brought you a truck, how would you test it? Okay, Alan Turing came along, and you said,
This one's can't tell if it's a human driver or
"Yeah,
a
exactly,"
autonomous driver. Yeah,
but not the human because humans are
it's
flawed.
different, but
Yeah,
yeah.
yeah,
How do you actually know you're ready,
yeah,
basically? Like, and
yeah,
how do you know it's good
yeah.
enough? Yeah, and by the way, this is the reason why Waymo released a safety framework for the car side because one, it sets the bar so nobody cuts below it and does something bad for the field that causes an accident. And two, it's to start the conversation on like framing what does this need to look like. Same thing we'll end up doing for the trucking side. There it ends up being different portfolio of approaches. There's easy things like, are you compliant with all these like fundamental rules of the road? Like you never drive above the speed limit. That's actually pretty easy. Like you can fundamentally prove that it's either impossible to violate that rule or that in these like you can itemize the scenarios where that comes up and you can do a test and show that you pass that test and therefore you can handle that scenario.
Hmm.
And so those are like traditional structured testing kind of system engineering approaches where you can just fault rates is another example where when something fails, how do you deal with it? You're not going to drive and randomly wait for it to fail. You're going to force a failure and make sure that you can handle it in closed courses and simulation or on the road, and run through all the permutations of failures, which you can oftentimes, for some parts of the system, itemize like hardware. The hardest part is behavioral, where you have just infinite situations that could, in theory, happen, and you want to figure out the combinations of approaches that can work there. You can probably pass the Turing test pretty quickly, even if you're not like completely ready for driverless, because the events that are really kind of like hard will not happen that often. Just to give you a perspective, a human has a serious accident on a freeway. Like a truck driver on a freeway has, there's a serious event happens once every 1.3 million miles. And something that actually has like a really serious injury is 28 million miles. And so those are really rare. And so you could have a driver that looks like it's ready to go, but you have no signal on what happens there. And so that's where you start to get creative on combinations of sampling and statistical arguments, focused, structured argument where you can kind of simulate those scenarios and show that you can handle them, and metrics that are correlated with what you care about, but you can measure much more quickly and get to a right answer. And that's what makes it pretty hard. And in the end, you end up borrowing a lot of properties from aerospace and like space shuttles and so forth, where you don't get the chance to launch it a million times just to say you're ready because it's too expensive to fail. And so you go through a huge amount of kind of structured approaches in order to validate it. And then by thoroughness, you can make a strong argument that you're ready to go. This is actually a harder problem in a lot of ways, though, because you can think of a space shuttle as getting to a fixed point and then you kind of like, or an airplane, and you like freeze the software and then you like prove it and you're good to go. Here, you have to get to a driverless quality bar, but then continue to aggressively change the software even while you're driverless. And so,
And also the full range of environment that there's an external environment with a shuttle. You're basically testing the systems, the internal stuff.
Yeah.
And you have a lot of control in the external stuff.
Yeah. And the hard part is, how do you know you didn't get worse in something that you just changed?
Yes, sure.
And so, so in a lot of ways, like the Turing test starts to fail pretty quickly because you start to feel driverless quality pretty early in that curve. If you think about it, right, like in most kind of really good AV demos, maybe you'll sit there for 30 minutes, right?
Yeah.
So you've driven 15 miles or something like that. To go driverless, like what's the sort of rate of issues that you need to have you won't even encounter?
So let's try something different then. Let's try a different version of the Turing test, which is like an IQ test. So there's these difficult questions of increasing difficulty. They're designed, you don't know them ahead of time. Nobody knows the answer to them.
Right.
And so is it possible to, in the future, orchestrate basically really
obstacle
difficult
course almost of like,
that maybe change every year, and that represent, if you can pass these, they don't necessarily represent the full spectrum.
That's it. Yeah. They won't be conclusive, but you can at least get a really quick read and filter.
Yeah. Like you're able to, because you didn't know them ahead of time. Like, I don't know, probably
like construction zones, failures,
or driving anywhere in Russia.
Yeah. Exactly.
Snow.